In the last video, we covered some basic definitions. We talked about the definition of statistics, and we talked about the definition of data and the definition of data value. In this video, I wanted to talk about the purpose of collecting data. So what is the purpose of collecting data? The most simple answer would be that the purpose of collecting data is to learn about the world. But what are some more specific reasons for collecting data? We'll talk about 3 specific reasons for collecting data, and we won't cover all the technical details and all of the formulas that are involved, but we'll just give a brief overview of those 3 purposes of collecting data, and I'll try to give 1 or 2 examples of each one. One reason for collecting data is to make predictions. So we'll put prediction down here as one purpose of collecting data. Prediction involves using a known piece of information to predict an unknown piece of information. It might be a little bit too simple of a definition, but it works for right now. Predict an unknown piece of information. So what could be an example of this? A person who owns a business might want to predict next year's sales, but next year's sales is an unknown piece of information because the future hasn't happened yet, and the person right now at this time doesn't know what next year's sales will be. However, if the person has been keeping track of his or her sales this year, and the person has been recording their sales, then the person will know the amount of sales that they've made this year, or at the end of this year, they'll know what their total sales were for the year. So this year's sales would be a known piece of information, assuming the person kept track of it and recorded it, and the person could use this known piece of information, which is this year's sales, to make a prediction about what next year's sales will be, which is the unknown piece of information. And this won't be a perfect prediction, but the person will at least be able to use the known piece of information to get a rough idea of what the unknown piece of information will end up being. And in most cases, while most predictions aren't perfect, predictions are usually less than perfect when you use data to make predictions. You usually make a prediction that's not completely perfect, but is at least somewhat useful. Another example is estimation. Another purpose of collecting data is estimation. Estimation involves using data recorded from small groups of people or things to estimate, let's say using data recorded from a small group of people or things to estimate something about a larger group of people or things. And it might help if I give a couple of specific examples of estimation. One example is estimating the mean, which is the average. In this class, we'll talk about how a mean is an average. Of a large group of people. A person might be interested in what the average GPA of all college students in the US equals. And there's a lot of college students in the US. I'm not sure if this number is still correct, but last time I checked, there's 20 million 642,819 college students in the US. So, if you actually wanted to know what the average GPA of all of those college students is, you would actually have to record the GPA of every college student in the US. Or you would have to find a person who already recorded the GPAs of all college students in the US, and you would have to find a person who could then give you that data set that they already recorded. But there's no guarantee that a person has already recorded all of those GPAs. So all college students in the US. So, if, like I said, if you actually wanted to be able to calculate the exact average GPA of all college students in the US, you would have to be able to record the GPA of all of these college students, meaning you would have to record 20,642,819 GPAs. Then you would have to add up all of those GPAs and divide the total by 20,642,819. Assuming you recorded each GPA correctly, that would give you the exact average that you're looking for. But that's probably not possible because you either don't have time to record all of these GPAs, or there's no way for you to contact all college students and ask them for their GPAs, or even if you could, it might be really expensive to do that. So what you would do instead is maybe select a certain number of college students to be your volunteers, maybe a few hundred college students, and record their GPAs. For example, I'll just make up a number right now. Let's say you record the GPAs of 1,000 selected college students who live in the US, and then you calculate the average of those 1,000 people, meaning you add up their 1,000 GPAs and you divide the total by 1,000. After you do that, you'll have the average of your 1,000 volunteers, and you can use that average to estimate the average GPA of all of these college students. Meaning you can use the average of your 1,000 volunteers to at least get a rough idea of what the average GPA of all of these college students would be. And I think I said this, but I'll say it one more time. The average of your 1,000 volunteers is not going to be exactly the same, or it's at least very unlikely to be exactly the same as the average of all of these college students, but it'll at least give you a rough idea of what this average equals. So that's an example of using data recorded from a small group of people to estimate the average GPA of the larger group that they come from. What's another example? Maybe estimating a percentage of a large group of people. Let's use our same example again of all college students in the US, just to be consistent. So what percentage do we want to estimate? Maybe we're interested in what percentage of college students in the US live with their parents. So maybe we want to know, out of all of these college students in the US, what percentage lives with their parents. If we wanted to actually calculate the exact percentage, we would once again have to record data from every member of this group of people. We would have to ask all of these college students, we'd have to ask each of these college students if he or she lives with his or her parents, and then record all of their answers, and then we could calculate a percentage. But the problem is, we probably can't ask all of these college students whether they live with their parents. So once again, maybe we'll recruit a smaller group of college students, such as maybe 1,000 college students, let's say, and ask them if they live with their parents. And let's say that out of the 1,000 people, out of our 1,000 volunteers, 50% say they live with their parents. So 500 out of our 1,000 volunteers say they live with their parents. That doesn't mean that exactly 50% of all college students in the US live with their parents, meaning that doesn't necessarily mean that, let's see, 20, 6, 4, 2, 19. Just because 500 out of our 1,000 volunteers said they live with their parents doesn't mean that exactly half of all college students in the US live with their parents. But our 50% outcome could be could at least give us, or could at least hopefully give us, a rough idea of what percentage of all of these college students live with their parents. So once again, we're using data from a small group of college students to estimate something about the larger group that they come from, which in this case is all college students in the US. What's the third purpose of collecting data? The third one we'll talk about is called hypothesis testing, which is using data recorded from a small group. Once again, using data recorded from a smaller group of people or things to test competing possibilities about a larger group of people or things. What do I mean by competing possibilities? Well, a person might want to know I think this third purpose is the one that is a little bit more difficult to understand at first, but I'll try to give a simple example. A person might want to know, or a person might be interested in whether the average mean, or the average GPA of all college students in the US equals 3.0. So once again, we're talking about this number up here of all college students in the US. This time, the person isn't interested in, this time we're not estimating the average, but this time we're trying to make an all or nothing decision about whether we think that the average GPA is equal to 3.0 or if it's some number other than 3.0. So a person might be interested in whether the average GPA, the person might not be interested in estimating the GPA, but the person might just want to make an all or nothing decision about whether the average seems to be 3.0, or if it's not, or not 3.0. And how could the person make that decision? Well, the person could do the same thing we did up here. The person might select a smaller group of people or volunteers and record their GPAs. And based on the GPAs that they end up recording, or based on the GPAs that the person ends up recording, the person will make the decision about these two competing possibilities. And next we'll talk about some more definitions. I think this covers some basic examples. Maybe one more example of this could be a person might be interested in whether the well, usually they say that the typical person should get about 8 hours of sleep per night. So a person might be interested in whether the average number of hours slept per night in the US is 8 hours. So a person might be interested in, does the average person in the US get 8 hours of sleep? Or does the average person get a number that's different than 8 hours of sleep, meaning above or below 8 hours of sleep? In that case, the person is interested in two competing possibilities. Possibility one is that the average person in the US gets 8 hours of sleep per night. Possibility two is that the average person doesn't get 8 hours of sleep per night. And the person could record the sleep time. The person could recruit a certain number of volunteers and ask those people, how many hours of sleep do you get per night? And then the person could use that data to make the decision between those two competing possibilities. So yeah, next we'll talk about a few more definitions.